Okay, like this one. Have you all done? Okay. 我画吗？画一个，画两个。Okay, fast we do together here. If this is north, this is south, how? So should act it should be north to south, right? And how about dot? Dot means what?
Direction.
Okay, so now dot means now you got a pen. So you use right hand grip rules. Grip it, right? You grip it, right? Dot means what? Dot means in your direction you see what? You see a dot. Dot means go towards you. Right. Cross means go away from you. Okay, so now, so let's say this is you, right? This is your view. This is your view. So dot means go towards you. Right. So you should point to yourself. Right. Then what is the direction of your finger when you point it to yourself? It's suppose it's a circle. When we say circle means clockwise or anti-clockwise? Anti-clockwise. Now see, I mean, okay, you see here, opposite direction is hard. Hả? 不要紧啦，我反正也很不会画。Okay, right? So when you see the dot means you will see something like this, right? Hi. 可以。多1分钟，凯阳，1分钟。Okay, so now you can see your finger down, right? Your finger down means then you put 9 o'clock on your left, 3 o'clock on your right. Then you will see 9 go down to 3 is anti-clockwise. Can you always think as your clock? The 9 always on your left hand side. Amen. Okay, like so triangle. Okay, so now let's label anti-clockwise here.
Neighbor, what are you waiting for?
Anti-clockwise label 了吗？你不会的时候 you put 9 o'clock on left, 3 o'clock on right, anti-clockwise. This one also suitable to use in maths. Maths ล็อกไข่sorry. The transformation clockwise or anti-clockwise, remember? If you are not sure where to, you label this. Okay, for example, let's say this is 3, 4, this is a dot. We say rotate clockwise 90 degrees, where will it go? So you can treat this. I mean, you actually can treat the center is the center of clock. Yeah. So you can treat the center as center of clock. Clockwise means go down lah. So go down your after transformation it will be here. Can? Then now let's say I have another dot on here. I want anti-clockwise. So you treat this as your center. Anti-clockwise means yes, 9 o'clock, 3 o'clock. Anti-clockwise means goes down here. You also can apply in your maths, understand? Any science field can apply. You treat just put the center as the center of clock, then you put 9 and 3. Okay, y'all? Okay, so now next, what should we do? The direction should be come from north to south or south to north. North to south, to south, to south. 家人没有看 video 哦，特地为你录的啊。可以看了吗？特地为你录的，我还要跟5个人讲，特地为你录的。Okay, so this one. First of all, let's draw 3 points around the circle. 1, 2, 3. 1, 2. I mean, make them parallel, okay? The main 3 is around the circle. Okay, so now, you don't draw first, I draw first. So supposingly, it should go this way. But when they see the roundabout, when they see the roundabout, they should follow the roundabout. Understand? Suppose don't draw yet. I demo first. Then second, it's supposed to go straight, but it's blocked by roundabout, right? So it also will follow, go down and up. It's supposed to go straight, but also follow the pattern. Can see that? Okay, let's draw together. So it's supposed to go straight, but here go down. The roundabout go down here, so we need to follow. Can? Okay, once you finish the 3 already, you add 1 more on top and 1 more at the bottom lah. Because the 2 at the edge so not affected so much. Then can you see which part got more magnetic field line? Down bottom, right? So bottom will move the wire go upwards. So this is the pattern of the magnetic field line. Or you actually can use Fleming left-hand rules to see. How? Okay, so first of all, point a gun, then open half of your middle finger, right? So fix which finger first? Normally, yeah, south means mother go shopping, magnet go to south, can? So which finger is mother magnet? Index finger, father, mother, and I. 哎，想起来了，你看 video 了没有？特地为你录的video go back home Okay, so now mother point to south. Then this is current. Current go to yes, your side. Then can you see the thumb? Thumbs up, right? So force go up. Okay. So see from your direction, you cannot see my middle finger because it's 90 degrees block. Okay. Now how about this? How to point this? Same thing. Magnet go to south. Then how about current? Current goes out. For side view like this. Can see that? Current go away from me. Side view, current go away from me. Then you will see the force down. 左手，小姐，左手。Okay. Now, seems like you understand, seems. Okay, right now, next. Okay, page 126, like 126. The above activity shows that magnitude of force acting on conductor current can be increased by increasing increasing the current I and also increasing the the strength of permanent magnet. Or we can say by using of magnetomagnet. You may ask me, teacher, what is magnetomagnet? It's fridge magnet. Magnetomagnet is like this. It's flat. Okay, and then it's like fridge magnet. Magnetomagnet. Normally, what we draw like this is called bar magnet. Okay. So you can say permanent magnet or magnetomagnet. Magnetor is a type of magnet, the shape. Okay, so now how to increase the current? We can increase more battery means we increase not only energy to move a column of charge forward. Energy used to move a column of charge forward. Sorry? Yeah, voltage. Voltage refers to EMF and potential difference, right? What's their similarity? second one. The first thing is voltage again. What energy used to move solar charge from one place to another. And voltage means energy. EMF also energy. Okay. EMF not a force, but it's energy. Okay, using what kind of wire of same length? Okay, we read first. The wire with same thickness, what wire inside the magnetic field? Okay. We can say using, by the way, if you want to increase current, you need to decrease resistance. Okay. So using thicker or thinner wire? Thicker wire. Right? One lead. When using longer or shorter wire of same thickness? Shorter or longer? Yeah, shorter wire. Then using what wire inside? Using copper. Okay, copper cancel the off. Copper wire inside the magnetic field because all these three will decrease your resistance. So the magnetic field strength can be increased by using stronger magnet. And then place the magnet closer or away 1 C. Yeah, closer to each other. I believe all of you know, right? When you play magnet, you put closer, they will have stronger force, right? So actually, one direction is our basic requirement. So actually what we want the things keeps rotating. So how to make it rotating? So now, here, this one is, we learned this before, this is motor, right? And by the way, this chapter is really a little bit hard because you can't really see the magnetic field. So let's draw out. Okay, like I show you video first before we continue. Motor. Okay, this one we've seen before. We watched before. So we know that when two magnets put together, they will have a repel or attraction force. Okay. So if you want to make it rotate, you either use, we always change the pole of magnet lah, but it's lazy lah to change all the time. So why not we let them change themselves? So actually every metal inside got magnetic field. Just that their magnetic direction is not in same direction. But the current, if you put a wire and you make a current inside, yes, this current will make their magnetic field all in same direction. So it will become an electromagnet. Okay, then how to change the magnetic field? We just change the direction of current, okay? So how to change the direction of current? We can change the direction of battery. But same thing lah. So lazy lah, change like that. So we let them change themselves. How to make them change themselves? We use AC. You either switch wire or you switch battery. Okay, so now you can see we now replace the magnet with the electromagnet. So it will turn because of repulsive force. Then if we want to continue to turn, we change the wire again. Yeah, we keep changing the direction of current flow. Actually, what we want to change direction of current flow. Like what you draw before lah. Now see, direction go out, force go down. Direction go in towards you, the force go up. So you just need to change the direction of current. You can change the magnetic field so you can make it rotate. So now if we make two magnets together and we change current direction, then it will always rotate. But of course, we normally use what? We normally use the magnet in a curve shape so that the magnetic field is maximum. Okay, so now we change the bulb. We make it as armature. Can you see the shape? Armature. Armature have the shape like this. Okay, so you make the current go this way and come out. So it will keep rotating. How? Can you see now current go from this way in, that way out? 那么想睡觉了是吗？ Yeah, if you want it to continue, you always need to change the direction of current. Are you okay? Right, this one is a bit hard lah. And I first time see this, I really don't understand. I watch many times only I understand. So if we don't want to always change the wire, we can make a commutator here. This is a commutator, or sometimes we say it is. Sometimes we say it is. The ring is split. We call it as split ring. Split. 切一半. Split ring. So they are not connected to each other lah. So if we use a commutator, we no need change wire ourselves. 魏忠有在听吗 魏忠坐在那个死角，我时常看不到他。Okay, right? Then we connect it to a brush. This brush actually is a carbon rod. Not the really brush lah. Okay? So, but of course, this brush, can you see this brush got two surface contact, so they got a lot of friction. Now, can you see? Let's say this is rod A, this is rod B. So when the current go in rod A, then after that it will come out in rod B. Get the idea? Then what happened next? Can you see this is A, this is B? Now when it rotates later, this side will be A, this side will be B. Okay, like now this side is A, this side is B. But no matter how, if we stand here and see, we will see the current always go in left hand side, go out right hand side. So if we use a commutator and a brush, then we don't need to change the wire direction every time. See, so how intelligent? Commutator 它是分开的，对不对？哎呀，speak Mandarin 的话，OK， so 就是讲，刚刚这边是 A， 这边是 B， 可是现在 A 跑过来了 ，current 就从 B 进去，对不对？然后从 A 跑出来，但其实不要紧，因为当你在这里的时候，你看到的是 current 永远是你的 left hand side 进去的 ，right hand side 出来的。我们其实不在乎这个 commutator 是 A 还是 B， 我们只要 current 永远是从 left hand side 进去 ，right hand side 出来，这样它就是会一直转。
为什么我走在里面？
因为它一通电它就是 electromagnet 啊。然后你看啊，那 see if they turn to here， 看到吗？他们是 attraction force here got attraction force。always attract to opposite, but until here they will stop. So how are you going to make it continue rotate? You change the wire low. Yeah, they change wire. Because of this. Can you see? How to make it spin? We use south attract north down. We use north repel the north down. So this is bar magnet lah. But how to change the north or south for electromagnet? Change direction of current. Hey. Commutator makes us not change the wire. Okay, can you see when the current go in here and come out, it will turn the wire up. If you want to make it rotate always, you must make sure your current always go in from left hand side. One direction now. Now see, now when the current go this way, they stop already. So what should you do to make it continue? Yes, change wire because just now current go up. Then now the current go down. Then you change again, go up, go down. And do not worry, exam won't test you this. Exam will ask you explain this. This is in Form 6. You don't need to understand why. You don't need to understand how. You just need to understand how to draw. And you just need to understand you need to have commutator and a brush. 可以吗? Okay, you always as long as the current always go in one direction, it will keep rotating. Hả? Middle magnet. Oh, 它其实没有 magnet 的。Yes. This armature no magnet, but when it got current, it turns to a magnet, electromagnet. 看低调啦，乖。Purposely record for him, you know. I told this for 3 people already. Okay, then you can make them rotate faster. You can increase armature. And this is not enough yet. Can you see when they rotate? By the way, still not enough, so how? Yes.
Wow.
And see that? More armature rotate faster. Yes. So we will get a rotation torque lah. Now you understand why your fan can spin so fast? This one like it best because here got more coil together, more current flows through once. Okay, so what is a real life motor is like this, and we add a stator inside, rotator or stator inside. Now, this is the normal motor we see. Have you ever take out the motor from a toy car? 这样乖? Huh? Yeah, I believe all of you seen this before. So the real one is like this. Now the real one is like this. Can you see the armature? Sorry, this is commutator. So beside here inside is the commutator. Here outside, can you see? Nowadays they don't use magnet. Some they don't use magnet already. Both also they use electromagnet. Can save cost lah. Actually, magnet quite expensive. Now you understand how the motor makes things vibrated. Motor of your fan. Okay, then why I want to show you that, like, because we are going to draw this. Okay, like how to draw this. See, if we stand here, oh, okay lah. Our class still here. Okay, thank you everyone. Bye bye.